Hello everyone, so today I'm going to talk about calculating degrees of unsaturation. So in this video I'm going to talk about mainly with carbons and hydrogens, but in another video I will have a part 2 and I will discuss what would you do if you have a bromine or a nitrogen or an oxygen and how that would count. But first of all, you need the basics, right? And that's what this video is going to be about. I'm going to give you many examples just for you to get comfortable with the actual process of calculating the degrees of unsaturation and showing you what an alkyne would count for, what an alkene would count for, what would a ring count for. So that way, once you have it down, and then when we add the bromines, the nitrogens, the oxygens, it's going to be much easier. So don't scroll away. So what do you do to calculate a degree of unsaturation? Well, first of all, they're going to give you a formula. So you're going to have your given formula. Then you're going to calculate how many hydrogens you would have in the alkene formula. Okay, so what I tried to write was for hydrogen is going to be your 2n plus 2. And for your n, what you're going to put is the amount of carbons that you have. Okay, after you calculate the amount of hydrogens you would have, you would do the hydrogen difference. What is that? So the hydrogens that you calculate that a normal alkene would have minus the hydrogens that you're given in the actual formula. And if I'm going too fast, don't worry. As you can see, I have a ton of examples and you're going to have the practice that you need. And then lastly, what you're going to do is you're going to divide by 2. So let's practice together. So in the first example, I have C2H4. So I have 2 carbons. So I'm going to plug that 2 into the formula. So 2 times 2 plus 2. So for the hydrogens, it's 2n plus 2. Again, my n this time is going to be 2. So 2 times 2 is 4 plus 2 is 6. Now, in the formula that I calculated for my alkene, I have 6 hydrogens. In the formula that I was given, I have 400 hydrogens. So 6 minus 4 is 2. Divided by 2 is 1. Okay, so again, I have in the next example 6 carbons, so C6H10. So now I'm going to put 6 into my formula. So 6 times 2 is 12 plus 2 is 14. 14 minus 10, 10 from my given formula is going to be 4. 4 divided by 2 is 2. 3 times 2 plus 2 is 8. Again, I'm on the next one. 8 minus 6 is 2. Divided by 2 is 1. So try pausing the video and calculating the next ones. Okay, I'm going to imagine that you did, and let's keep going. So 4 times 2 plus 2 is 10. 10 minus 8 is 2, divided by 2 is 1. 4 times 2 plus 2 again is 10. 10 minus 6 is 4. 4 divided by 2 is 2. 5 times 2 plus 2 is 12. 12 minus 6 is 6. 6 divided by 2 is 3. 5 times 2 is 10, plus 2 is 12. 12 minus 8 equals 4. 4 divided by 2 is 2. 5 times 2 plus 2 is 12. 12 minus 10 is equal to 2. 2 divided by 2 is equal to 1. So what I have in pink are my degrees of unsaturation for each of those formulas. Now, what would I do with that number? Glad you asked. So with that number, what you can do is if you know that something has 1 degree, you can draw a ring. If you know something has 1 degree, you can also do a double bond, okay, an alkene. If you have 2 degrees of unsaturation, you could draw a triple bond. So I know sometimes students like to compare at the beginning because they're trying to learn, but with this, like with synthesis, honestly, you can have many different structures in general. I mean, maybe not if you have like this one that's C2H4. I don't think you're going to have a lot of different structures. But for the other ones that you have more carbons, like 3, 4, 5, 6 carbons, you can have many different structures. So don't get discouraged if it's not exactly the same as someone else. But do make sure that you are following the rule. A ring being 1, a double bond being 1, and a triple bond being 2. For clarification, an alkene is 1 and an alkyne is 2. And remember that. Okay, so enough talk. So for C2H4, we calculated 1 degree of unsaturation. So that is the only structure I think that you could really draw for this one. But for the other ones, for example, C6H10, we have 2 degrees of unsaturation. So you could draw, for example, a ring and a double bond. Again, a double bond is 1 and a ring is 1, so 1 plus 1 is 2. You could draw your regular 6 carbons and draw like 2 alkenes, or you could draw 2 alkenes, like 1 on each end. Or you could draw 1 triple bond, or you can do an internal triple bond. And so I had, in other words, you can have a terminal alkyne or an internal alkyne. That would be the proper term. Likewise, you could have terminal alkenes, or you could have a terminal and an internal alkene. So I wanted to show you that you can have many different structures. And if you want to ever check, and I'll do it at the end and I'll show you, for example, you can count your amount of carbons and you can count your amount of hydrogens. And that's how you check that you did it correctly. Like if you're confused, you're like, I don't know if this structure is right, just count the carbons and the hydrogens. And I mean, don't do that always, right? But like if you want to check and you're at the beginning, especially because you're not sure, that's a way you can check your work is right. Okay, so let's go for C3H6. Again, you can draw a ring or you could draw a double bond. You can draw, again, double bonds, or you can draw 4. Notice that the amount of carbons I'm putting is what I have in the formula. What is changing is where I have my double bond or if I put a ring. And again, all of these structures are going to add to the amount of hydrogens that we said. Okay, so for C4H6, I could have 2. So I drew these different structures. I drew a triple bond, an internal alkyne, terminal alkyne. I even drew terminal alkenes. I drew a ring and an alkene, just so you can see you really have many different structures. Okay, for C5H6, again, I drew, again, an alkyne, and because this one was 3, so I drew an alkyne and alkene, because 2 plus 1 is 3, obviously. Or you could do a ring, and you can do 2 double bonds. You could probably even do, well, forget that, but see how you have many different structures. And then for C5H8, I drew all these different structures. Again, it's mainly, because it's 2, I drew 2 alkenes, or I can drew an alkyne at the end or at the beginning. I also drew a ring with an alkene. And then for the last C5H10, I drew these different structures. Okay, now for the check, because sometimes you're like, what do you mean you can check your work? Because some students don't see it. So I'm going to show you with like the easiest structure. This one in pink, so C4H8. So you have 2 hydrogens here, 2 hydrogens here. Remember, you have a hydrogen and a hydrogen like that. 2 hydrogens here and 2 hydrogens here. So what I'm trying to show you is that is 8. So you ended up with C4H8, which is what your given formula has. I'm gonna erase that now because it looks kind of weird. But you really do have 2 hydrogens in each of those, and that's what you wanted from the given formula. For the other ones, you can actually count. So for example, here you have 3 hydrogens, 2 hydrogens, 1 hydrogen, 2 hydrogens, 2, 4, 5, 8. So again, it was C4H8. So we did it correctly. So that's what I mean by you can actually check your work and not just, fret about like, did I do this correctly or not? Again, a ring is 1, a double bond is 1, a triple bond is 2. I challenge you to actually watch this video again and try to draw the structures without looking at these that I have. Pause the video before I show all the different structures and try to draw them yourself and see how many structures did you get from mine. Did they match up? Did you do at least 2 or 3 of them? Because the more practice, the better. And you will likely have this on your exam, especially Chem 1, you will have like draw this structure. And so definitely you should get all the easy points where you can. I will make another video, part 2, with nitrogens and bromines and oxygens, so that way you can see how it would be affected with that. But again, if you like this video, it takes time to create this content, so please follow, like, share, and thanks again for watching.